Okay, question 6. This is set 1, Swyk 2. Suppose you start with 1,500 bucks. Well, that's obviously your A value, your starting amount, and then you're going to get an interest rate increase of 5%. That's laughable. Banks aren't giving out anything near that. So this is definitely not a savings account. A CD wouldn't even come close to this. You would actually have to put your money in a riskier investment for this, at least at today's interest rates. So we're starting with 100%, and we are going up by, let's see here, let's get a different color, 5%, so that would be 105%, and so I converted that by moving the decimal 2 places to give me 1.05. Now, they wanted to know about 4 years. So I'm going to put this in my 4, and so when you go to your calculator, now I'm going to be using Desmos.com. You can use whatever you need, but $1,500 at that would give me 1823.26. 1823.26. So I'll write that down. Okay, but what if they changed it to 17 years? Okay, so I'm using Desmos.com as a calculator in this particular case. 17 years would be $3,438.03. To be quite honest, the bank's going to round down, not in your favor, but that's okay. 3438.03. 3438.03. It goes on to ask, well, how much time would it take to get to $2,000? And then eventually $2,500. Well, folks, we will eventually have a very, very efficient way of solving this. At the current moment, we don't. So we are going to guess. You're like, what do you mean guess? Yep, we're gonna guess. Okay, so let's see here. Now I look at that and I'm like, okay, 4 years gave me 1823, so I'm gonna go a little bit bigger than that. What if I said 5 years? Wait a second, I'm on the wrong one. Let's go back here. Let's change this. Let's go 5 years. Ooh, getting close. How about 0.5? 5.5. Ooh, a little bit more than that. 5.7. Ooh, I'm going to guess it's going to go all the way to 6. Yeah, look, you're at 6 years. It's pretty close. It's a little bit less than that, but, you get the idea. Okay, let's pause for station identification. So, that's 6 years. We took a guess. We got just a little over 2,000. Now we'll try 2,500. Okay, so 6.5. Oh, not even close. Let's try 7. Oh, still not close. Let's go to 10. 10. We're getting warmer. 11. Not 111. We'd be dead by then. Okay, so between 10 and 11, if you really wanted to get, 10.5. Ooh, 10.5. That's really close. Okay, so we're going to get a much more precise way of doing that. We don't use guess and check. That's amateurish, but that's what they wanted in this question anyway. So that's what we did. Okay, so we'll put that over there, and looks like Math Excel wanted a whole number, as it says right here, so we went with 11, even though we know it's 10.5. Just a smidge under 10.5, to be quite honest. All right, question 7. Moving on down the road. Exponential growth. Okay, we're growing at 4% per year, so we're starting with 100%. We're going up by 4%. That means we're at 104%. If we move the decimal over 2 places, we get 1.04. Hey, that's the growth factor. And we've got, we're increasing by 14 years. Okay, so now I'm going to go back to Desmos. So your equation right there is starting at 130,000, you got 1.04 to the x power. But we're going to plug in a 14, and we'll go over to Desmos here and see what we get. Looks like my 130,000 turned into 225,117.94. Here, I'm going to write that down. Wait a second. I use my annotate. Oh yeah, 225,117.94. Okay, now I can jump back over to my notes. Pause. Come on. Oops, that, and then that, and then that. That gets me $225,117.94. Next question. We should get rid of that. Alright, so question 8. Caladan is currently one of the world's fastest growing countries. That's a great made up name. I've never heard of that one. The exponential function is y equals 69 times 1.031. Now, what they're saying is that the original population was in millions, right? So they're starting out with 69 million people, right? And the starting year is 1974. So when we plug in an x value of 0, we're really talking about 1974. Okay? So they have to have a starting point, and so 0 matches up with 1974. It does look like we are growing at a rate of 3.1% per year. That's the growth factor here. Okay, so when we substitute in a 0, well, guess what? Anything to the 0 power, 1.031 to the 0, that's going to be 1. So when you multiply it times that, we know that the answer to this is 69. We don't even need to type in a 0. We know it. Now, when I put in 23, which would be for the year 1997, let's go see what Desmos has to say about that. Jumping over here. 23. Okay, so 139,000. They want me to then go up by the increments of 23 years. So they want me to go 46. And then they want me to go to 69, I believe. Going up by 23 every single time. So let me just write this down so I have kind of an idea of what's going on here. We've got 139.25. And then we go to 281.03. And then we go to 567.15, okay? We'll round it off, okay? So I'm going to keep those numbers because Desmos is going to ask me, or I'm sorry, my notes are going to ask me some other questions here. So obviously we can write that down, you know, the 139. They want to the nearest tenth, so that would be to 139.3, I believe, unless I screwed that, unless I double rounded. I hope I didn't double round. Did I double round? Nope, I didn't double round. Okay, whew, good. And then the year 2020, that's the 46 years after. So I took the 2020 minus 1974, and that's how I got the 46. I did that ahead of time, so that's why I knew I was going to plug in 46. And so that's my 281.03 or 281. Now to the nearest tenth, and then 567. I better jump back. 567.1. 567.1 for the last one. 567.1. So what they're asking is what happens, what appears to be happening in Caladan's population every 23 years? Is it tripling? I hardly think it's tripling. If I took 69 times 3, that would be 207. Nowhere near. 139.3 divided by 69. So that's a little over 2. And then if I took 281 and divided by 139.3, that is another, okay, we are basically doubling. That's what we're doing. We're doubling every single time. Every 23 years, we're doubling the population. Interesting. Now that's a 3.1% every single year, ends up doubling in 23 years. That's what you end up finding out. So we are multiplying by 2 each time to go from one to the next. But that's a 23-year increment. We found out the last one was 69 by taking 2043 and subtracting 1974. That's how we knew we were plugging in 69 years. Okay. I can get rid of that now. On this last, is this the last question? Yep. On this last question we have here, we were given a home value of $99,000, and we were given an inflation value of 6%. So we wanted to know how much the home value was going to be inflated after 16 years. So it's $99,000 today. What's it going to be worth in 16 years? Now, that's a little bit of a bad way to say that, because everything's going to cost more 16 years from now. Anyway, so using this 1.06 to the 16th power, let's go back to Desmos here. We've got our $99,000 home, 1.06 to the 16th power. That would be 251. 494 point. Okay, I'm just going to write this down. 251, 494.82. So now I can come back to my notes. Oops. And that's what I end up to the nearest dollar. Okay. 251, 495. To the nearest dollar. And that completes this Swyk. See you later. Come on, I'm trying to hit the right button.